G'day. Copy the heading down and then we'll do some hard yakka. We will start by testing your knowledge, so put down the numbers 1 to 10 under your heading. Question 1. What adjective word do we use to describe how metals can be beaten into shape? Question 2. What is the adjective word we use to describe how metals can be drawn out into wire? Question 3. Which group or column in the periodic table contains the most reactive metals? Question 4. What metal can be extracted from sea salt using electricity? Question 5. What is the metal that can be extracted from wood ashes? Question 6. Do metals tend to gain or lose electrons when combining with a non-metal? Question 7. Where are nonmetals found in the periodic table? Question 8. What do we call a mixture of two metals? Question 9. Which metal age followed the Bronze Age? Question 10. Metals are good conductors of heat and what? Maker heading the alkaline earth metals of Group 2. In our previous video, we looked at some alkali metals of Group 1. In element form, they were the most dangerous of metals, exploding violently with water, forming strong, caustic metal hydroxides plus hydrogen gas. Their compounds tend to be soluble in water, so we find them in nature in seawater, evaporated inland seas, and the watery parts of living cells. Alkaline earth metals, in element form, also react with water, forming metal hydroxides and hydrogen, but they do so less violently. Their compounds are often insoluble in water. This is why they are called the alkaline earth metals. Their compounds are found naturally in rocks. Magnesite, or magnesium carbonate, chalk or limestone in the White Cliffs of Dover, calcium carbonate, strontianite or strontium carbonate, and barytes. Now you can list some of the properties of these alkaline earth metals. First, write the colour of these metals. Second, the colour of their compounds. Count how many electrons there are in the outer shells. So write down the valence number for column 2 metals. Put a side heading beryllium Be. Roughly 15% of Australian family wealth comes from the mining and export of minerals. Australia's major mineral provinces are concentrated in Australia's oldest rocks, which are found in the western 2/3 of the continent. The Archaeozoic rocks in dark blue date between 2.5 and 4.6 billion years old. The mid-blue Proterozoic rocks date between 2.5 and 0.5 billion years. Notice that the Broken Hill area in far west New South Wales includes some of these Precambrian shelled rocks. The area is mostly flat, weathered, brown and dry, with occasional rock outcrops to interest these students during a school expedition in 1972. About 1 kilometre under this test diamond drilling rig is the world-class silver-lead-zinc ore body, which was first mined by the BHP company over 100 years ago. But I am more interested in this pegmatite quarry being run at the time by an elderly widow whose husband had been blown up in a quarry accident. The Triple Chance mine produced big felspar crystals formed when magma intruded a fault line. In zones within the felspar is a beryllium aluminium silicate mineral called beryl. Beryl crystals are typically yellow-green with 6 sides. Being element 4 in the periodic table, beryllium is used in a variety of high-tech applications that need a very light metal. It finds uses in ceramics, electronic devices, space vehicles, aircraft disc brakes, computers, televisions, calculators, microwave ovens and nuclear reactors. But beryllium has a big problem. It is not an element of life. Indeed, its dust and compounds are severely poisonous to most living things. Some people develop an allergy to the element, and it damages the lungs in a similar way to asbestos. Make a side heading magnesium, then make observations one at a time in point form. The most vital chemical of life on our planet is the green chemical chlorophyll, which is found in all plant leaves. Chlorophyll has the ability to absorb the blue and red parts of white light energy and to use that energy to turn water and carbon dioxide into food. At the centre of the chlorophyll molecule is magnesium. Magnesium is found in black minerals that also contain iron. Geologists call these black minerals ferromagnesian minerals. They are common in igneous and metamorphic rocks and include augite, hornblende and biotite mica. So if you want to pick up good farming rocks, choose basalt or granite or other igneous rocks. Old limestones contain calcium carbonate. The calcium can be partly replaced by magnesium from nearby igneous rocks, forming dolomite limestone. Nursery suppliers grind up dolomite rock for use on gardens as a fertiliser. It is an alkali that can neutralise and sweeten the sour acids in our increasingly acid soils. It also contains the calcium needed for milk and bones and the magnesium needed for plant chlorophyll. Magnesium is one of the most people-friendly elements in the universe. Its compounds are generally quite harmless. Magnesium hydroxide, or milk of magnesia, is used in antacid tablets. Epsom salts, or magnesium sulfate, are good for citrus trees, but too much of this mineral water from Epsom in England will give humans the thundering trots and feel the need to use this appliance invented by an American gentleman called Thomas. But all elements have their dark side. You can obtain magnesium metal element by putting electricity through molten magnesium compounds, such as this ore mined in Queensland. The lightweight magnesium metal will find increasing uses to reduce the weight of cars and aircraft. Mag wheels are already famous, and magnesium is being used in engine blocks. You can burn magnesium on a heat mat as long as everyone in the lab is wearing welding goggles that cost about $5 in order to block out ultraviolet light. The magnesium ignites at about 470 degrees Celsius and burns at around 2200 degrees Celsius, forming a white powder called magnesium oxide. The heat of burning magnesium is intense. The ultraviolet light emitted can damage the retina of the eye. Here magnesium flares are being ejected from a transport aircraft to fuel heat-seeking missiles that would normally explode against its hot engines. Terrorists often fire these missiles from the ground near airports. The problem with burning magnesium is how to put the fire out. Here someone has lit up magnesium on a concrete path. So he hit it with a garden hose with nice cooling water to block out the oxygen. Oh dear. This car is burning after an accident and the bodywork contains magnesium. Enter Fireman Sam on the left. Oh my, thank goodness he has protective clothing. Magnesium burns in steam by taking the oxygen out of the water, leaving the hydrogen, which can explode the fire. So Mum wants to bring out the big guns and try a carbon dioxide fire extinguisher. But wisely we do an experiment first. The good professor starts magnesium burning on a block of intensely cold solid carbon dioxide that we call dry ice. Then he covers the fire with another block. The magnesium grabs the oxygen out of the carbon dioxide and burns in that. So how do you put it out? You cover it with dirt, lots of dirt. It is an absolute disgrace that this amazing element of life was turned into the principal weapon of mass destruction used to destroy whole cities in World War II. Put our third heading, calcium, and make notes as before. Being lower in group 2 than magnesium, calcium is the more reactive metal and forms calcium hydroxide and hydrogen gas with water. It takes work to ignite the calcium metal, but when it does so, it flashes with a brilliant ruby flame that needs welding goggles to observe safely. Because of its reactivity with water, the element calcium has very few real uses. In fact, any dentist that tried to fill your teeth with calcium would probably blow your head off and would thoroughly deserve to treat a patient that looks like this. The importance of calcium is to be found in its compounds. This table shows the percentages by weight of common elements in the Earth's crust. Use the table to write down the percentage of calcium in our crustal rocks. You can probably figure out which two elements are found in nearly all common rock minerals. The second table shows the percentages of the main ions dissolved in seawater. Write a statement about the percentage of calcium found in sea salt. Can you figure out which sodium chemical is the most common compound found in seawater and sea salt? The Proterozoic rocks north of Adelaide, shown in blue, and the younger Cambrian rocks, shown in green, provide valuable insights into how animal life first appeared in the Earth's oceans. The rock layers at the top of the Proterozoic era occur in the Ediacara Hills in the Flinders Ranges. The Ediacaran fossils are world famous as some of the earliest multicellular animals. These fossils shown are jellyfish, and this is a type of worm. At the base of the Cambrian period rocks above it, we suddenly have animals with hard parts. These are sponges, and these are trilobites, which dominated the oceans for 200 million years. The shells, skeletons, and hard parts of these animals are made of calcium carbonate. All animals with skeletons have a need for calcium. We obtain calcium by eating milk, fish, and dairy products such as milk and cheese. Those who follow the vegetarian or vegan regime have to work very hard to get the vital iron and calcium that they need in their diet. The ancient Chinese needed to be able to survive on soybeans, which are quite deficient in useful calcium. To replace the calcium in their diet, they use powdered limestone and powdered gypsum to make tofu products in a complex process, using the ground up soybeans. Once sea animals began making hard calcium carbonate shells, limestone reefs began to form. In New South Wales, there was a barrier reef extending from Yass in the south to Jenolan in the north during the Silurian and Devonian geological periods around 400 million years ago. These are some fossils from the Yass area. At Jenolan, acid water began dissolving some of that limestone reef, forming some of the oldest caves in the world. Limestone is also found in other parts of New South Wales. These fossil corals come from Scone. Of course, our modern-day barrier reef is found off the coast of Queensland. In Britain, limestones are found along the south coast. These are Cretaceous squid-like animals from dinosaur times. Another microscopic shelly animal formed extensive chalk deposits along the Dover coast and in France across the Channel. They have been easy to carve to form pictures. When you heat calcium carbonate, it forms calcium oxide plus carbon dioxide gas. The calcium oxide is called quicklime because it reacts very quickly with drops of water, forming calcium hydroxide. Calcium hydroxide is called slate lime because it is lime which has slaked its thirst. The decomposition of calcium carbonate in lime kilns has been going on for thousands of years. Old lime kilns are found in Europe, Britain and New Zealand. Australia is dotted with its lime burners creeks and lime kiln bays like this one near Karua on the north coast of New South Wales. It was the job of the poor old convicts to collect leftover shells from ancient Aboriginal kitchen middens and to roast the shells in kilns. The slaked lime produced was used as a mortar to cement cut sandstone blocks or as a crude whitewash paint for the walls of the houses. We Aussies have progressed a long way since the convict days. This is the age of megacities, so we grind and cook our limestone on a massive scale. Back in the old country, in cities like Bath, the upper classes made their mansions from a honey-coloured limestone called Portland stone that was mined on the island of Portland near Dorset. In the 1800s, a number of experimenters developed a process for making a similarly coloured cement powder, which is generally called Portland cement. This cement works at Berrima in New South Wales uses local limestone as the main ingredient. The kiln can reach temperatures of 1400 degrees Celsius, much hotter than your 600 degree Bunsen. Other ingredients include clay, shale, sand, iron ore, gypsum, bauxite, fly ash and slag from the BHP. The dangers of using cement powder are often ignored. Its pH is 13, making it a very strong alkali that can damage your hands. So wear gloves. The fly ash power station waste can damage your lungs, so wear a mask when the dust blows. You only get one pair of lungs, and our massively overworked doctors can do little to help silicosis victims. So be responsible for your own safety. Next time you take a block of land with living soil and cover it with concrete, spare a thought for the future. There has to be a better way. Gypsum is the second most common calcium compound found in nature. It is formed when inland seas evaporate, leaving behind a number of salts including gypsum. Gypsum is hydrated calcium sulfate, containing 2 water molecules within the crystal structure. Australia has deposits near Ivanhoe in western New South Wales. Other deposits are found in European countries near the Mediterranean Sea. This deposit formed when the Mediterranean Sea dried up in the Miocene geological epoch 15 million years ago. When you heat gypsum, it loses some water, forming a useful product called plaster Paris, which forms plaster when you add water. Plaster has been placed on walls for thousands of years. It is found in mosques and in the Sistine Chapel in the Vatican, and even in my home. You can see the fibrous strings inside the sheets. Modern gyprock is fine, but in the past some fool mixed asbestos mineral with gypsum to make fibro sheeting. I grew up in fibro houses like this one. The problem with asbestos can be seen in its sharp needle-like fibres as seen under the microscope. This slide shows a single fibre in the lungs which is triggering cancerous growth around it. Eventually the vital base of the lungs can look like this. When working with or demolishing fibro sheeting, the sheeting should be wet and you should wear full space gear like this. Even small exposures to asbestos can kill, as the late courageous Bernie Banton reminded us. Old fibro sheeting needs to be buried deep, and old asbestos mines avoided like the plague. Copy down this information for the metal strontium. Strontium is a dark grey metal which is kept under oil to prevent it from reacting with air or water. Its compounds have rather limited uses. Its flame is a brilliant crimson, so with gunpowder, strontium salts make very pretty red fireworks. Strontium salts also tend to replace calcium in bones if you take them by mouth. Being heavier than calcium, strontium can strengthen bones in osteoporosis sufferers who can easily break hips and need specialist reconstructive therapy. The radioactive form of strontium, or strontium-90, also tends to end up in bones. This is one reason why atmospheric nuclear tests have been banned, as they produce lots of this dangerous isotope. Copy down this information for the heavy metal barium. Barium is an extremely reactive dark grey metal which needs to be stored in an atmosphere of the inert gas argon. It is found in nature as the mineral barytes, which is barium sulfate. Barytes is a mineral which is very heavy and quite insoluble in water. In flames, barium compounds give off a green light and so are used in green fireworks. This perhaps should be discouraged, particularly over harbours, as soluble or acid-soluble barium compounds are quite poisonous and will paralyse the heart. Indeed, barium carbonate is a very useful rat poison. Heavy, insoluble, non-poisonous barium sulfate has many uses. You can swallow it, or have it squirted in the rear end as an enema to allow useful X-rays, searching for cancerous growths and other abnormalities. The white stuff that ends up in the toilet is quite heavy. Another use for barium sulfate is in drilling mud in oil wells. Another compound, barium oxide, is used to coat electrodes in fluorescent tubes, allowing them to emit electrons more easily. Copy this information about a metal that glows in the dark. The uranium oxide ore, pitchblende, is mined in a number of parts of the world, including Australia. Uranium is the heaviest naturally occurring element and is in need of a weight reduction campaign. Uranium atoms slowly spit out bits for billions of years, eventually forming stable lead atoms, as it changes from one heavy radioactive element to another. Radium is but one step in the decay, and one of the nastier ones. The really bad radioisotopes don't last very long, glow in the dark, and form a very tiny amount of the pitchblende ore. 1/10,000th of a gram per tonne. Pierre and Marie Curie concentrated radium chemically from tons of pitchblende ore working in an old tin shed in 1898. Radium atoms are alpha particle emitters, the worst type to get inside you. It forms a worse radioactive gas called radon, which is a major pollutant in natural deep spring waters. Pierre Curie was weakened by radiation and killed by a horse and cart. Marie and her daughters continued their research and died prematurely of cancer. Their pioneering work with X-ray machines, diagnostic radiation and radiotherapy continue to save millions of lives today. But radium metal is nasty and has no real uses. Some old entrepreneurs imagined it to be warming and good for the health. So they sold radium chloride as a health tonic. Many died painfully of bone cancer. Other legends set up factories to extract radium from pitchblende and to paint it on watch dolls to make the watches glow in the dark. Such a factory was found on Sydney Harbour at Hunters Hill. The girl workers put brushes in their mouths to paint on the rhodium. Most died horribly of the throat and tongue cancers that are usually found only in fools that smoke tobacco and marijuana. So you'd better be careful in the art classes. Till next time, cheerio.